So after talking about carbohydrate metabolism, it only seemed logical to talk about fat metabolism. So we've got one main objective here, and that's understanding, going over how hormones regulate or control fat metabolism during exercise. Okay, so when it comes to fats, you have to remember it's a huge source of energy, right? We've got about 70,000 calories worth of fat in our bodies that we could use for energy, as opposed to the 2,000 or 3,000 calories of carbohydrates that we've got. And so fats are really important for endurance performance. But in order to be able to use them, we need to break them down. And so if you recall from last week, we need to break these down. And there's many different types of fats, but the one that we most commonly use are triglycerides, which are found in adipose tissue, so just fat, as well as in muscle. Okay, so when the process by which we break down fats is called lipolysis. Okay, and then once we break down these fatty acids, we're able to take them up into the cell, and once they're in the cell, they can undergo beta oxidation, which we talked about in lecture 2.2. So if you remember, beta oxidation is basically taking these fatty acids, which are just long chains of carbon, and breaking those chains of carbons into pairs. And then from there, we can create acetyl-CoA. Acetyl-CoA goes through the Krebs cycle, and then NADH, FADH2 go through the electron transport chain. Okay, so this is nothing new, but how do hormones regulate these processes, or this process? Okay, now insulin is important when it comes, as is epinephrine, norepinephrine, and cortisol, and growth hormones. So we've got 5 different hormones here. So we talked about epi, norepi, and cortisol really helping out with carbohydrate metabolism during exercise. But we're going to add insulin and growth hormone. Okay. Now, if you recall, epi and norepi also help us take up glucose, right? They stimulate glycogenolysis. So we're breaking down glycogen into glucose. Well, those hormones also stimulate lipolysis. So we're breaking down fats into those fatty acids. Cortisol also does an excellent job of liberating or breaking free or separating, or however you want to look at it, free fatty acids that we can use for energy during exercise. As we discussed last time, though, cortisol is a little bit slower to really kick in those increases in concentration. It takes 30 to 45 minutes for that really to set in. So this process, especially with endurance performance, we have high levels or high activity of fat metabolism when we have low levels of carbs. Okay, but remember that as we go with exercise performance, one of the problems with using fat, even though we've got essentially an unlimited supply, is that it takes longer for fat to break down. And so if we have to rely on fat for long duration, maybe slightly higher intensity activities, we're going to fatigue faster once we start relying on fats.